This morning I'm going to talk to you about functional automation tools, asking, does the relentless rise of open source functional test automation tools herald the end of the commercial tool market? How have commercial and open source functional automation tools evolved over the last 20 years? And how does the market look today, and what does the future hold? For this presentation, we focus on tools used for the functional automation of application user interfaces, typically web browsers, thick client applications, mobile web browsers, and mobile apps. This is typically achieved by the automation tool interacting with the application interface objects and controls, such as buttons, input boxes, text fields, etc., etc. Now, in some cases, it is achieved at a level above this by using visual image and OCR-based techniques, along with simulating coordinate-based mouse clicks and keyboard actions. We also touch on tools used for the functional automation of APIs and service-based interfaces by orchestrating multiple calls together as a functional test. Now, I'll start with a bit of a history lesson around commercial automation tools. Test automation can be traced back to the 60s and 70s, but I'll start midway through what I'll call the Windows era with the traditional and original tool vendors. Driven by requirements to automate the testing of client-server apps via native Windows interfaces and an increasing number of browser-based web applications, the early key players by 2000 were Qtp and WinRunner from Mercury Interactive, Segway with QA Partner, later named Silk Test, and Rational Software with Rational Robot, previously SQA Robot. Now, these tools were largely targeted towards testers, providing them with the functionality to help record, customize, and script automated tests without the need for development skills. Mercury was acquired by HP in 2006, Segway by Borland also in 2006, and Rational by IBM in 2003, and then by Micro Focus in 2009. Rational Robot became superseded by Rational Functional Tester. QTP was renamed UFT in 2012, by which point WinRunner was no more. LeanFT was introduced in 2015 as a response to the ever-increasing competition from developer-friendly solutions in agile and continuous testing environments. There'll be more on LeanFT later, as it's a good example of how the traditional players have responded. And more recently, HP Tools was acquired by Micro Focus in 2017. It's also worth pointing out a few other similar tools who joined the market later, including SmartBear's Test Complete, Tosca's Test Suite, RanaRX, and Telerix Test Studio. I've also included Parasoft's SOA Test and SmartBear's SOAP UI in there as tools that can achieve functional automation via APIs and service-based interfaces. And then finally, Eggplant, probably the most popular visual image-based OCR-based automation tool. So what are the key characteristics of these tools? They are typically standalone, licensed, one-size-fits-all tools with multiple technology support, e.g. web, Windows, terminal, SAP, mobile, API service. They have a combined automation framework and execution engine, i.e. the creation of tests and the driving of the application. Built-in test execution, reporting and analysis functionality and dashboards. Scriptless automation through recording, object recognition and repositories, drag and drop actions, assertions and waits. Data and keyword driven approaches. The ability to custom code where required, with earlier tools using languages such as VBScript and even proprietary. Later versions often with image-based OCR techniques, and they are typically aimed at non-technical testers rather than developers. The vendors of these tools typically aim to provide support and training rather than relying on a community of users. Moving on to the rise of open source. The first batch of tools are what I'll call true open source, and we'll start with the ubiquitous Selenium, first developed by ThoughtWorks in 2004. Selenium continues to dominate the web automation space with a large ecosystem built around it. Quick trivia point, the name Selenium was used as this was a cure to mercury poisoning. And a key point and misconception around Selenium is that it is a standalone functional test automation tool. As the Selenium website states, Selenium automates browsers and that's it. What you do with that power is entirely up to you. Now, this is a common theme with a lot of the open source options, with tools such as Selenium requiring code and frameworks around them to achieve test automation, often with multiple languages. Appium was introduced in 2012, and along with the rise in mobile, is still one of the key open source tools for mobile automation and is built following the Selenium architecture. Calabash is another popular open source mobile automation tool, although not as successful as Appium. We then have JavaScript-based variants and wrappers for Selenium, such as Protractor and WebDriver IO, catering for the rise in JavaScript-based development in UI frameworks such as AngularJS and React. I've included Rest Assured here as an example of a popular open source service-based tool. We have tools such as Securely, an open source visual image-based OCR tool. White is one of the few examples of an open source tool for native Windows automation that continues to have very limited open source support. I guess the lack of a logo says it all. Now, these are all tools that execute automation, typically with a framework and scripting required around them. We then have a number of open source frameworks that can drive these execution tools, common ones being Cucumber, Robot, Frameworkium, and Serenity, but there are literally hundreds out there. And finally, it's worth mentioning tools that have open source elements but follow freemium models, such as Sahi, SoapUI, and Postman, the latter two being popular service automation tools. So what are the typical characteristics of these open source tools? So they are web and mobile technology focused around increasingly complex user interfaces and solutions. As mentioned earlier, they are typically split into execution tools to be able to automate the application and the frameworks that sit around these to allow automated tests to be scripted and configured. They typically have limited reporting and analysis, although some of the frameworks are strong in this area. One common limitation, and is often a key reason for selecting commercial tooling, is the lack of Windows and legacy architecture and technology support. They often appeal to the more developer and dev and test community rather than the non-technical test community. They are typically lightweight and tend to be suitable for continuous testing and integration environments. And they typically require low-level coding to develop test automation and often work with common IDE environments. And support is via communities, so the more popular tools typically grow in popularity exponentially. Now, as mentioned previously, Selenium and Appium have a significant commercial ecosystem around them, typically platforms that let you run Selenium and Appium-based tests against a wide range of web browsers and mobile devices, both real and emulated simulated. These include Source Labs, BrowserStack, Perfecto, and Experitest. And indeed, a lot of the funding for developers of open source tools such as Appium is commercially funded by companies like Source Labs. I'd now like to cover what I'll call a new breed of automation tools, mostly Node and JavaScript based, none of which use Selenium or Appium, and two of which follow freemium models. So we have Cypress. It's a JavaScript based automation tool, but it's limited to Chrome browsers only at the moment, but I believe Firefox is coming very soon. Now, Cypress follows a freemium model. We have Test Cafe, again JavaScript based, cross-browser support, can be used with Source Labs and BrowserStack. That also follows a freemium model. We have Puppeteer, open source. It's an open source JavaScript framework from Google with support for Chrome and Chromium only. And finally, worthy of mention is a tool called WinApp Driver, an open source Windows automation solution. This is following the Appium architecture to automate native Windows applications. Now, most of these tools follow further support lightweight continuous testing and continuous integration trends, appealing to development skilled users and the increasing popularity of JavaScript for web development. Now, finally, before I move on, one of the tools to consider and mention at this point is Selenium 4. This next release is rumored to be available later this year, I believe, and brings some significant changes around the way that it drives browsers, bringing greater control, but it'll be very interesting to see what actually comes with Selenium 4 and when that is delivered. In the mobile space, we have three tools that, unlike Appium, run within the mobile app and therefore tend to be more stable. These are XCUI Test and Earl Grey for iOS and Espresso for Android. And we are certainly seeing an increasing use of these tools with our customers over the last year or so. So how have the traditional tool vendors responded to the ever-increasing open source and new breed of test automation tools? Common themes include greater language support and common IDE integrations, such as Eclipse and Visual Studio. We have a number of them adopting freemium models to encourage adoption. We have re-architectures to become lighter weight to support Agile and DevOps models. We have Selenium and CI integration. And typically the balancing of their legacy strengths and focus around non-technical users and technology support across multiple architectures and technologies, with appealing to developers and dev in tests. So a couple of examples here, and I mentioned it earlier. We have LeanFT, which I think came around in 2015, which was largely a ground-up rewrite of HP's UFT offering. Multiple language and IDE support, lightweight to support Agile DevOps, current and legacy technology support. So rather than just supporting the latest web technologies, HP looked to replicate the wide technology supported UFT with LeanFT. And it has things like the LeanFT for Selenium extension. Another brief example here is Ranorex with their Web Test It, which is an IDE for building Selenium and protractor tests, but sits as part of the wider Ranorex ecosystem. So moving on, is this kind of response working? A recent survey in 2018 asking which automation tools are you currently using shows the continued dominance of Selenium, Appium and Cucumber at 73, 24 and 33% respectively. Commercial tools include HP UFT at 17%, Test Complete at 8% and Ranorex at 6%. So to conclude, are commercial test automation tools dead? So certainly a convergence of test and development is driving an explosion in test automation tools, particularly in the web and mobile space. And there is no doubt that the traditional commercial tool vendors are under increasing pressure from open source and the new breed of freemium tools. Innovation is absolutely key to their survival. Trends around Agile, DevOps, continuous testing and continuous delivery have changed the landscape and user base significantly. And we have commercial vendors, we have new commercial vendors providing platforms for open source tools and freemium models while supporting the latest technology trends. And finally, it's worth noting that progress in the AI machine learning automation space is dominated by commercial players, but that's a whole topic for a different discussion. So that's it for today's presentation. Thank you for listening. We now have time for a couple of questions if any have come through. Let me just take a look. Let's have a look. Okay, I've got one here asking, how do I automate the testing of microservices? So I guess, let me think about that. So I guess the first point around microservices is largely from an interface perspective. Microservices presents a REST-based web service interface typically. So any tools, be they commercial or open source, they can test a REST-based web service interface, will work with microservices. There are challenges, and the complexity of testing and automating the testing of microservices is around the testing end-to-end of one microservice and its integration with another. So you may want to use tools that exercise the REST-based interface of a microservice, and then at the back end simulate other microservices that microservice may be communicating with. So we have tools, sort of service simulations, stubbing tools like WireMock that could be used to simulate back-end microservices that are consumed by another microservice. There is also a tool called Pact that's out there. It's quite a low-level tool that focuses on the concept of, I think it's called consumer-driven contracts to drive the testing of microservices. And that's used typically in development and delivery environments where there are a number of microservices being developed and the teams all collaborate using Pact and publish instances of their microservice to allow the testing of microservices together. Okay, that's it in terms of questions. Thanks again for listening and have a good day. Thank you all.